Hello everyone and welcome to Swift Heroes. Hope you are all well and safe at home. I'm Giampiero from Subito's iOS team. We are proud to be prime sponsors of the event and we are waiting for you folks to join our virtual stand. Thank you and enjoy the conference.
Good morning, everyone. Let's talk about SwiftUI in production. SwiftUI currently, and I'm talking April 2021, is in this really uncomfortable position where it's showing a radically different way of building UI, but it's also being so new that it's risky to use. One hears both people praising it and people cursing it. There are small samples that show how amazing SwiftUI is, and on the other hand, you see random attributed graph errors and all the things that are missing from Swift. So, can you use it? Should you? We wanted to know, so we tried it and recently shipped a major new feature built almost entirely in SwiftUI, while also still supporting iOS 12 in our SDK. In this talk, I'll show you what we learned. Now, who am I? I'm Peter Steinberger and I live in Vienna, Austria. I started working on iOS when we still had Vue did unload, and I really enjoy working on difficult problems. I tweet a lot, mostly about iOS topics, and especially lately, I'm digging deep into SwiftUI. You can follow me on Twitter at StyPete and experience the highs and lows of learning a new technology. I also have a blog at stypete.com and I write a bunch of articles for PSPDFKit, the company I founded in 2011. Now, for those of you who haven't heard of PSPDFKit, we're a small distributed company that focuses on solutions to show, annotate, and sign documents. Mostly PDF, but we also added support for Office and Images files a while back. You can display them, annotate, fill forms, digitally sign, merge, flatten, you name it. We're available on all platforms and have a custom built UI for each platform. We chose this path so the product feels like a natural extension of the OS and not a cross-platform compromise. I've been fairly critical towards SwiftUI for a good year, but hearing reports from others how amazing SwiftUI is, I really wanted to give it a go. So there is quite a famous blog post of mine called The State of SwiftUI, where I take apart Apple's Fruta example code. And Fruta is a SwiftUI multi-platform app, so its native features in AppKit and UIKit. And it doesn't use Catalyst here. The AppKit bindings specifically have been rough, and it was, and still is, quite easy to crash the example after playing with it here for not even a minute. Apple picked up my critique internally and the situation is quite a bit better now. However, if you really try, you can still crash the app by monkey clicking around for a few minutes. The good news is that this isn't really normal user behavior, and I'd argue that I can break quite a lot of apps if you just give me enough time. If we look, we get very close to me crashing, and here it already is. In fact, that's a crash related to NS Toolbar and the bindings there. Now, the good news is that the iOS bindings for UIKit are quite a bit better quality-wise. Now, before we started the project, I needed a lower risk target to learn SwiftUI. I did pick the settings dialog in PDFViewer, a free app for iOS and macOS, and we use Catalyst on the Mac, which made this an especially interesting target. And we also dropped iOS 12 here already in preparation for adding SwiftUI, so it's been a relatively contained project. And what I did here is I first rewrote the existing settings in SwiftUI. So this is what you see here as the group table on the left. And after we shipped the rewrite that didn't change the UI in any meaningful way, I went away and redid the settings to be proper Mac settings dialog. And we're actually reusing the code here in iOS and macOS. And just styling it very differently. And this turned out to be amazingly easy with SwiftUI. I'm gonna write about this eventually. So if you're curious how that's gonna done, follow me on Twitter to not miss that. Now, let's talk about the feature that we built in SwiftUI. For this release, we had the goal of greatly improving the signing flow in PDF documents. Signatures are an important use case, and we've been supporting PDF signing for years. With the new flow, you can now not only sign via drawing your signature, but also via scanning an existing signature or via typing your name. This is a flow common in most signature solutions. The previous UI has aged quite a bit, and it was originally written before Apple introduced auto layout. A very good candidate for a rewrite. Regarding OS compatibility, we plan to drop iOS 12 later this summer when we start working on iOS 15. So until this happens, the existing drawing signature flow stays in the product for the iOS 12 users. And if we detect iOS 13 or later, and with the current license bits, we show the new flow instead. Now, we're at a Swift conference here, and every third talk online is about SwiftUI. I probably don't need to sell you on the idea that SwiftUI is great. For us, it's an attractive target because it greatly simplifies the flow of updating views. It's much harder to make update-related bugs, and it's easier to reason about the UI state at any given moment. Another reason that writing UI in code with SwiftUI is just so much more expressive than doing the same in UIKit. We do not allow interface builder or storyboard in our codebase. Anyone who tried to resolve merge conflicts in these files will understand why. All our UI is built in code, and having to maintain less code is always a win. Another benefit is that it can be mixed with existing code. Our draw view is highly optimized with features such as natural drawing and predictive touch to make drawing with the Apple Pencil on modern 120Hz iPads an almost magical experience. We use quite a bit of tricky math in here, and it's been written in ObjectiveC++. Now, I argue that this currently can't be built in pure SwiftUI. There simply aren't the APIs there that you need. And if you deal with a great number of points, a more strategic way of reloading is beneficial to performance. Now, this might not be strictly necessary for a signature, but we can reuse the draw view we use on PDF pages as well. So we save, again, quite a bit of code. Now, did I mention that our SDK was started in 2011? So it's a lot of code. And until very recently, namely Swift 5, we couldn't use Swift as our customers needed binary compatibility. So there's still a lot of Objective-C code in there, and it's not realistic to rewrite everything just for the sake of rewriting. But don't worry, this will be the only slide with Objective-C on it. Now here's how we call the new feature. The SwiftUI code is encapsulated in a UI hosting controller. Presentation is handled by by UIKit. And SwiftUI is fairly contained in this component. If we detect iOS 12, we defer to the legacy signature component, which still works perfectly fine, just isn't as feature-rich. And if the new component, we do use navigation view as a base and present it there. So the main difference is that the controller doesn't need to be wrapped in the navigation controller if we detect the new one. And that's basically all there is to it. We also expose the PSPDF signature creation controller itself in both Swift and Objective-C, because our product is used by many large enterprises, and many of them still use, at least to a degree, Objective-C. So we want to give our customers a choice, and ultimately they don't need to know that the new component uses SwiftUI. In fact, they don't need to care at all, it just works. Now, let's talk about the challenges of SwiftUI. And in this presentation, I'll refer to SwiftUI for iOS 13 and Catalina as SwiftUI 1. And SwiftUI for iOS 14 and Big Sur as SwiftUI 2. Supporting SwiftUI 1 especially has its challenges. Often when people write about this cannot be done in SwiftUI, they're both right and also very wrong. The beauty of SwiftUI is that you can freely mix it with UIKit or AppKit on the Mac and add all the missing functionality yourself or work around bugs. Let's explore some of the workarounds we had to polish the electronic signature component. Now, in adding hacks to SwiftUI 1 is also a fairly safe operation because the OS already shipped and it's done. iOS 13 is not going to change anymore. SwiftUI 1 is done. So even if you apply a really dirty hack where you query the view hierarchy and do introspection, it will work reliable if you test it because it's no longer changing. Shipping such things for iOS 14, for SwiftUI 2 and further is more risky, especially because in a few months when there's WWDC 2021, I expect that many internals of SwiftUI will change again as Apple will do a great leap with SwiftUI 3. Oh, and since I'm sure some of you have this question, we found that SwiftUI previews are not working for us. This is sad. They do work in small projects, but in our project they frequently timed out and just showed random errors. That's an area I really hope Apple will improve, and I also believe they do, because previews are insanely convenient to iterate. But even if they don't work, you're still much faster than writing plain UIKit or AppKit. Now, let's start with something that looks innocent, but really isn't. When our signature screen is in landscape, in a compact environment, we use a popover to show the font picker. Now in SwiftUI, popovers are always presented as sheets in compact size class environments. With the adaptive presentation style, it's possible, I think since iOS 8, to show popovers even on iPhone via returning none in the delegate. Now there's no equivalent for that in SwiftUI. And of course, it's possible to rebuild the whole popover completely yourself. However, getting all the details right is not trivial. And it just seems more work than using the existing UI frameworks. So to mix and match the two worlds, we need a few tricks. Presenting popovers in UIKit needs a source view to anchor the popover on. You need the frame coordinates, and you also need a view controller to present. We have nothing like that in SwiftUI by default. However, if we embed a UIKit view into the SwiftUI hierarchy, we can access that and both get the view and ultimately the view controller from there. In our codebase, we have a class called AnchorView that resolves the view and passes it on tab to the action that is being called. And we can use that view to show our font list controller. The font list controller offers a convenient present method to present itself on a view. Now this is straightforward logic, as you know from UIKit. Since we also need a view controller, we have a helper here, sender.pspdf_closest view controller. And what this helper does, it simply crawls up the responder chain via calling next responder until it finds a UI view controller to find to you. However, the responder chain is documented to enclose both views and view controllers. So really, this is safe, and even Apple does this internally in UIKit sometimes. The remaining logic is in view.load, where we simply add the signature font list SwiftUI view via a hosting controller again. We use a helper to set up the auto layout constraints and child view controller relationship. To dismiss the view, we pass back a closure that calls dismiss on the container view controller. Again, this isn't something that wherever you tap, the popover would dismiss itself, but we optimized our UI so there's certain areas where you can tap through for a better experience. So therefore we use the closure to programmatically close the popover when we need to. Now, when there's enough space, we don't need a popover and we can use signature font list in SwiftUI directly. Currently this pop-up presentation code is just used in the font controller, so we haven't made it a generic control yet, but it would be pretty easy to make it a reusable component and use it in different parts of our code base. We usually apply Yagni here, you ain't gonna need it, and we'll refactor this as needed. Another benefit of this approach is that we're working around the bug. We're having multiple different popover modifiers in SwiftUI doesn't work until iOS 14.5. Now, let's get back to the anchor button once more. It's by far not as tricky as you might imagine it. Internally, the struct wraps a regular button and adds a wrapped UI view behind the button via a set stack. I could probably also have used a background to do the same, but I wrote this a while ago and it's working really well. We keep track of the UI view and pass it as a parameter on the closure that is called when the button is pressed. And that's already everything that's to it. I'm linking to both the gist and the blog post explaining this in way more detail. Feel free to use this code whenever you need it. Now, let's talk about the Toolbar API. SwiftUI 2 introduces the new Toolbar modifier, which greatly improves how toolbar items can be added. The new API gets details right, such as marking the done button confirmation action bold to match the UIKit experience. On iOS 13, SwiftUI 1, we have navigation bar items leading and trailing. However, there's no simple API to center elements in the toolbar, which is what we do in landscape orientation for compact size classes. What we use here is we use the amazing SwiftURX project as a temporary bridge to get similar functionality. It offers a navigation bar items leading, center, trailing API to basically do the same that we do in iOS 14. We will drop this code once you can drop iOS 13 to keep it simpler, to keep the simpler, more modern solution. Now, if you look at that code, you might think that we're duplicating some parts here and that we could further simplify it with a conditional view modifier. And in many cases, this is true. However, since the toolbar API is not available on iOS 13, we need to use available, which doesn't directly work in postfix expressions. The Swift language team is working on this problem, and there's a proposed solution currently in evaluation, namely SE308. Now, SE308 is a proposal to support if for postfix member expressions. Once this is implemented, we can further simplify the conditional logic. And currently it's looking as this is coming quite soon. Let's talk about every SwiftUI developer's worst nightmare: attributed graph precondition failure. This crash usually has no symbols of your own code, and working around it is often quite difficult. The strategy, honestly, is to change things randomly and praying that it starts working. Luckily, it doesn't happen a lot. To test out our new signature component, we first shipped it in our free PDF viewer app. We did closely monitor crash rates, and of course, eventually we saw the error with an invalid input index 2. And the crash only happened on Mac Catalyst and only when it was running on macOS Catalina. Now, I've seen this type of crash before, namely in Apple's Fruta example app, and often it involves geometry readers. Geometry readers have been a source of bugs for a long time. Apple did fix a whole lot of problems in iOS 14.2. And since our signature UI is highly adaptive, we didn't manage to build it without geometry reader. However, we had one case where we had nested readers. And to be honest, this is a code smell, and usually it's possible to modify this to need at most one geometry reader. We just didn't know better at the time. When you encounter a crash, look for a geometry reader that is not at the top level and consider simplifying your views. Since our crash was exclusively a problem for Catalyst, and there are no compact size classes in a Catalyst app, we simply don't call the inner metrics callback and assume enough size not to switch to a small presentation. So not calling metrics here was enough to work around the crash on SwiftUI 1. Another quirk you should be aware of is that of Observable Object. Observable Object doesn't work for objects that inherit from NSObject in SwiftUI 1. We need this base class since we still support API access for ObjectiveC, and the addObjectiveC attribute requires NSObject as a class parent. We've been working around this issue by manually defining and calling ObjectWillChange. This workaround can be removed once we drop iOS 13, and it behaves exactly the same as the automatic version does. Of course, we could also use this by creating a separate class for the ObjectiveC compatibility layer that then forwards to this model. However, this approach is less boilerplate and ultimately more elegant. Another common complaint in the SwiftUI can't do this category is setting the first responder. When the type mode is tapped on our signature UI, we want to automatically show the software keyboard. And while folks are correct that there is no API in SwiftUI to do that, it's also something you can very easily work around. My guess is that this is one of the areas where we see improvements in WWDC 2021. How we can solve this? We can access the inner UI text view that SwiftUI uses with a custom view modifier. Once resolved, we simply call become first responder on this view. And in our example, as an added benefit, getting access to the internally used UI text view also enables us to set a custom return key type, which is also missing in SwiftUI. The text field finder helper is a simple UI view subclass that overrides didMove to window and then crawls the hierarchy to find the UI text view that is added by SwiftUI. Now, you need to be aware that this is undocumented. There's no guarantee that SwiftUI still uses your text view once it hits version 3. So you'll need to be smart about this. In our case, the worst that can happen is that we don't show the keyboard automatically anymore. Everything is still usable, so we are okay in using this pattern. Even more, I argue that the introspection pattern is something that we see as absolutely necessary for a real polished SwiftUI app. The popular SwiftUI Introspect library implements this feature via Introspect text field and offers access to many more controls for both UIKit and AppKit. In fact, there's a pull request open where I open up even more controls, especially on the AppKit side. Now, again, this is a hack and it's not something that's documented. So, unlike, for example, the responder chain trick that I showed earlier. So, if you require access to an UIKit or AppKit control for a critical feature, then wrap the view yourself. You can guarantee that SwiftUI isn't changing the implementation underneath you. Wrapping is quite easy, and ultimately the experience is basically the same because it's more or less the same control that SwiftUI uses. Now, some bugs are easier to work around than others. We noticed an issue in SwiftUI 1 where setting a value other than 1 on minimum scale factor would cause an endless layout loop after deleting the last character on the text field. As a workaround, we simply don't scale in this case and use a custom view extension, we call it save minimum scale factor, to generate this workaround. The experience for iOS 13 is still pretty good, and eventually we can just remove this hack once we drop SwiftUI 1. Now, you've been seeing that we've been wrapping custom views quite a bit here and there. Most of the time, it's the same boilerplate code, and we can write a small helper that makes this much simpler. Remember our fine-tuned ObjectiveC++ based raw view? Here's how we wrap this and configure it in barely 3 lines of SwiftUI. And of course, changing selected color automatically rebuilds the SwiftUI graph, and we get all the benefits of SwiftUI's performant view diffing, even for our existing UIKit views. The wrapper is a straightforward generic struct, and we expose an update block to make it easy to configure the view after it's being created. Now, in the signature view, we modify the UI after drawing a signature and only enable the add button after there's actual content to insert. To do that, we use a combined publisher because that just works really well with SwiftUI. Our publisher maps a publisher on the draw view that fires every time points change. We count if there's any points and map the result to a Boolean. That publisher then is bound to an isValid Boolean on the model object. And ultimately, isValid changes if the button on the top right is enabled or disabled. This is all quite basic combine, but again, this is something that SwiftUI really encourages, and it makes the code easier to reason about. Now, I mentioned that the draw view has been written before combine existed, and it's not even using Swift. To offer a publisher there, we convert the older way of doing things, a notification, to a publisher. And Combine has this really convenient publisher extension on Notification Center to do just that. Here, we simplify the logic and actually map two different notifications into one new publisher and return that publisher in an extension to DrawView. We use this trick in quite a few places. It's a very effective way to make older parts of your code base simpler to work with newer parts that might use SwiftUI. Let's talk about keyboard avoidance. SwiftUI 2 has great automatic keyboard avoidance built in. This feature doesn't exist in SwiftUI 1 at all, so we had to retrofit it ourselves. In this example, the signature view is added, the keyboard view is added to the signature view below the bottom toolbar and has an initial height of 0. Once the keyboard comes up, the height is modified with the calculation of the overlap, so everything important stays tappable. Keyboard view wraps a simple UI view and has one binding to communicate the intersecting keyboard height. This all looks very simple because the actual logic happens in the view coordinator. You can see that we implement make coordinator at the bottom here to have additional logic. The coordinator is a class and not a struct, and SwiftUI will keep it alive for as long as our wrap view is displayed. In it, we listen to the keyboard will change frame notification. Once we get it, we get the keyboard rect, compare it to the coordinates of the hosting controller, and then calculate the intersection height and ultimately set that on the binding. This is a little bit gnarly code because keyboard are tricky beasts, and we also correctly deal with situations where the keyboard is not docked. Now, since the form sheet where we present the controller itself is UIKit, it does move up for the keyboard automatically. So what we do here is we use ditch.q main async to operate one run loop later. So UIKit does the keyboard moving work, and we can more easily calculate the intersection where we need to move up our content just a little bit further. In order to get the same behavior on iOS 14, and here in this case to keep the code simpler, we disabled the automatic keyboard avoidance on iOS 14. Once we drop iOS 13, we likely clean this up, but our code is perfectly safe, so there is no pressing need to have branching logic here or to change anything, even once we drop SwiftUI 1. Now, if we fit everything together, here is how keyboard view is used. Initially, it has a frame of 0, and you see that we insert the state into the view and then adapt the height based on the state variable. All right, let's summarize what we learned about SwiftUI today. We talked about the state of SwiftUI, how you can mix it with existing code, even Objective-C, how to present popovers, how to custom toolbar logic. We talked about geometry readers and how they can be danger, about the helper to make wrapping views easier, about the first responder, and lastly about retrofitting combine and keyboard avoidance. Thank you very much. Any questions?